Good day, we are group number 5 and we will be discussing one of the key figures in scientific revolution, specifically the man who completely revolutionized modern science, Sir Isaac Newton. The scientific revolution has greatly influenced our understanding of the nature of the universe. It emphasized developments in mathematics, physics, biology, chemistry, psychology, and many more fields of science. In this video, our group is going to discuss Isaac Newton's contribution in the scientific revolution and to society as well. Firstly, who is Isaac Newton, and what did he contribute to be a key figure in scientific revolution? Isaac Newton was an English physicist and a mathematician who became well known for his discovery of gravity and the laws of motion and his co-invention of calculus. Regarded as a scientist with a reputation for following every lead, he pulled together the findings of previous scientists into mathematical laws to explain how the universe functions. Along with developing the law of gravitation, he was the first to quantify mass, inertia, force, velocity, and acceleration. He also discovered that by utilizing calculus, we can explain how our planets move and why their orbits are in the shape of an ellipse. In fact, one of his most popular breakthroughs is that the gravitational force that holds us down is the same force that causes the orbiting nature of the planets around the Sun and the Moon's orbit around Earth. Newton's idea of calculus best demonstrates the direct link between the field of mathematics and the field of physics. In 1687, he published his most acclaimed work entitled, in English, Mathematical Principles of Natural Philosophy, or mostly known as Newton's Principia. It formulated all of Newton's findings, including the laws of motion and traces of calculus which helped him with his calculations. It became the single most influential book on physics, as it shaped many scientists' understanding of the physical universe for 3 centuries. His work also built the foundation of mechanics and how it is easily quantified through mathematical formulae. Although he feared the criticism of his fellow scientists as he was working on his theories, he persevered and made an important mark in history. Because of his contributions, he is credited as one of the greatest minds and became a key figure in the scientific revolution of the 17th century.
How did calculus become well known in modern science, technology, and society? Isaac's invention of calculus changed the view of science in a modern era. Why? Because from his point of view, calculus is viewed as a scientific description of generation of motion and magnitude. If you remembered our lesson involving calculus of motion that explains the motion of an object in either plane or space. That is a great example in how calculus changed science. Because of the possible description of scientific problems even with only using numbers. With this point of view, we use now calculus to solve modern problems that involves generation of motion and magnitude, like problems involving impact, tension, and many others. Now with the idea, technology take apart. Because with the knowledge about the generation, we are now able to predict possible outcome that may occur. So invention of new technology will have more percentage of success. Calculus has a lot of contribution about technology. So basically, it's well known. Since a lot of problems about technology involves calculus. The reason behind this is that the possibility of calculus for solving problems about application, simulation, and physics engines. Now, after that, people now start to recognize the capability of calculus. Majority of engineering schools, science schools, and other schools have topics and courses involving calculus. Calculus now become famous with the society because of the capability of solving equations that can see through future outcomes. So many schools train their students to solve calculus questions that will have great help for them in future once graduated. Now, majority of for what I see now, majority of students fear calculus because of its complexity, because of constant equation formula is being discovered daily or monthly. That is why calculus become more and more well known. Hence, its capability is too much.
Calculus is used in all branches of math, science, engineering, biology, and more. There is a lot that goes into calculus, and there are a lot of industries that really rely on it heavily. Engineering is one of the sectors that uses calculus extensively. Mathematical models often have to be created to help with various forms of engineering planning. And the same applies with the medical industry. Anything that deals with motion, such as vehicle development, acoustics, light, and electricity, will also use calculus a great deal because it is incredibly useful when analyzing and quantifying the changes over time. So it is quite clear that there are many industries and activities that needs calculus to function the right way. There are also other advanced physics concepts that have relied on the use of calculus to make further breakthroughs. In many cases, one theory and discovery can act as a starting point for others that come after. For example, Albert Einstein wouldn't have been able to derive his famous and groundbreaking theory of relativity. It wasn't for calculus. Relativity is all about how space and time with respect to the other, and as a result, calculus is the center of the theory. In addition, calculus is often used when data is being collected and analyzed. The social science, therefore, must rely on calculus very heavily. For example, calculating things like trends in rates of birth and rates of death wouldn't be possible without the use of calculus. An economic forecast and predictions certainly use calculus a great deal. The economy would function in a very different way if we didn't have calculus and other important mathematical concepts and inventions to explain and predict physical observations.
So what are the practical application of calculus to science? An example of these is physics, chemistry, engineering, technology, and architecture. So let's start with physics. Physics is a great example because calculus is mostly used in physics, like when we are computing for volume and more. Also, it is used when we are deriving for a formula, when we are deriving something in order to get the formula for the volume. The next one is engineering. In engineering, calculus is used to determine everything like length, width, and height of something, like wires and for infrastructures. Next is technology. In making and designing something, an accurate design and information and also computation should be done in order to make the design safe and working. Example of this is when engineers are designing for rockets and planes. They first use calculus, make sure that what they are computing is right, so that it will be considered safe. The next one is architecture. In architecture, it is used to improve something in design. And the last one is chemistry. Chemistry is another example with the use of and help of calculus. We can determine the rates of chemical reactions and a lot more. So in conclusion, we can say that calculus plays a huge part in science. We can also conclude that Isaac Newton's calculus has a huge impact not just in science but also in our daily lives.